0 equal to delta S, H equal to your when I write it like this, then we assume that there is a summation over mu. Okay? If you suppress mu, you could write it x dot delta x dot x prime delta x prime. But if you like, you could write the mu. So one up is stairs, one down is stairs. Okay? So that determines a covariant expression. Fine. Now let us consider these two terms one by one. Let me call it first, let me call it second. So in one of the terms, what I have is t 2 factor of 2 microwave. Okay, so t d tau d sigma x dot delta x dot. Now this delta x dot I could write as this is delta x mu. Okay. If you like, you can put mu here, mu here, mu here, and mu here. Okay. And now these two operations being infinitesimal operations, I can interchange. Okay. So I could write it as t x mu dot. Now delta x mu. And now I could use integration by parts. So I define it first part. On this, let me call it I1 I2. So first part into. So let me go ahead here. T and let me leave this sigma behind. I want to take integration with respect to tau. So I do it. First function x mu dot into integral of first function into integral of second. So delta x mu minus integral of differential of first into integral of second del tau delta x mu. Is it readable? It's readable. So this is, let me do it here, t d sigma. Now this, as you can see, is x mu dot. So I have not exchanged. Let me exchange tau and sigma. So this is delta x mu, right? So here you get simply delta x mu minus. So this is this term minus integral of d tau. This is d tau and this thing goes away. This thing is delta x mu. Right? Is this okay? So I have one of these terms and one of these terms. But here all integrations over time were over. So this is one big. So this into this. So this is a double integral. Okay. Now here this term, because these are definite integrals. Okay. These are definite integrals. So some initial time up to some final time, let us say minus infinity to plus infinity, and this delta x mu would vanish at the minus and plus time boundaries. So this term would drop in. Only this term would survive. Okay? And this term I could very well write as, so this is also a boundary term, but this is a time boundary term, and it vanishes on its own because of the presence of delta x mu. And delta x mu vanishes at the infinite time boundaries. So at some point minus, at some point initial final time minus at the initial time, but it is this thing would always be 0. So this term gives me identically 0, and I am left with only that term which is minus of, there was t here, and x double dot, if you like, I can write as x mu double dot into d tau d sigma. Okay? Alright? And when I do this, then can I remove this thing? I just leave this term here. Okay? When I do it with this, I will have another term del 2 sigma of x mu. And this term with that corresponding term would give me the equation of, let me just leave it here, like minus t. There is overall 1 minus integral d sigma was there, d tau is there. Let me just write x mu double dot, no problem, I can change it later on. Okay, into delta x mu. So this term let me leave here, and now let me look at this second term. Okay, so I would do a similar thing there, and so in my I2 I have minus t, 2 is gone, d tau d sigma, x prime mu delta x prime mu. Okay? Yes. Now this term I want to write, let me forget about this. This term I want to write as del tau del sigma x mu. This I can write as del sigma of del x mu. Okay? Right? And therefore, here I have minus t. Now I leave tau here, and I want to make partial integration with respect to sigma. So this is first and this is second. So first term x prime mu into integral of second. So this is minus integral of, so minus integral of differential of first into integral of second. So and then d tau, and this would give me only delta x mu, x prime, but at the sigma boundaries. Okay, which means this value at sigma equal to L minus the same thing at sigma equal to 0 or sigma equal to So at both the ends, okay? And this is minus, this is the tau is there. So d tau d sigma x double prime mu, and this is delta x mu. So you see what we are left with is, this is one term from the first partial integration over tau, and this is another term. I should have, yeah, there is a minus here. This minus I did not take, so what did I do? Minus here and minus t here, so it is plus, okay? Because these two terms should appear with opposite signs. These two terms should appear with opposite signs. So when I connect terms in my 0 equal to delta s, I would have, this would be the one term, and this would be one term, and this would be another term. So if I have minus t here, then I would have this, or if I like, but plus this boundary term, plus this boundary term. So this is minus t integral d tau times x prime delta x mu at your